Hey guys, welcome back to my channel. My name is Aditya and today we will be discussing about COVID-19 data analysis. So let's get started. First, I would like to take you to my Jupyter notebook in which I have coded this complete project. So as you can see, the headline is COVID-19 data analysis, which was a very important topic considering the past 2 to 3 years. As you can see, the first cell contains all the importing of the required libraries which we want, such as NumPy, Pandas, Matplotlib, and Seaborn. This is known as data preparation, so I have used this keyword data preparation above it, and then we are reading our CSV file using worldometer underscore data.csv, which is my CSV file stored in this in a particular directory in this Jupyter notebook. And then I would name it as world underscore data, and I would keep the index of it as country slash region. Then I would say world underscore data dot head, which would bring up around the first 5 rows of my data frame. So here it is, the first 5 rows of my data frame. The first column is country or region, continent, population, total cases, new cases, total deaths, new deaths, total recovered, new recovered, active cases, serious slash critical cases slash total cases upon 1 million population, deaths per 1 million population, total tests per 1 million population, and WHO region. The WHO stands for World Health Organization. So according to WHO, which region does the country comes in? This is known as WHO region. That is, USA comes in Americas and India comes in Southeast Asia. So let's move ahead. Now we are creating a build underscore graph function which will build our graphs for every particular x or y variable we want. So instead of coding our graphical code again and again for multiple graphs, we can basically shorten our code and write a particular function so that it will reduce our code length. So here it is, you can pause the video and see what I have written in this function. I have first imported matplotlib, then I would call the plt.figure from matplotlib, and I would set the figure size as 20,8, and then using the seaborn library I will bar plot, and the my x axis would be country slash region and my y axis would be y underscore label, and I would use the first 20 countries of my data frame, which would look like world underscore data, the starting 20 which we are indexing the first 20 countries, and then the first my first graph would be about total cases. So let's see how it looks like. USA had the maximum total cases around 5 into 10 to the power 6. As you can see, it is in the power of 6. And then Brazil, then India, then Russia. The lowest cases among top 20 countries were in France. The highest were in USA, around 5 into 10 to the power 6. India stands 3 in this. Now we'll build graph according to total deaths. So maximum deaths were again in USA, which had the maximum number of total cases. Second was Brazil again, but third was Mexico, not India. India was third in this total cases, but not in total deaths. So you can compare and play with these graphs as you want. Next, we will be building graph according to total recovered, like how many of them recovered who were tested positive for COVID-19. Again, USA tops the list, and then comes Brazil. Here, India is again third in total recovered cases. Next, we will be plotting active cases, how many cases are still there. So again, USA tops the list, then comes Brazil, then comes India. So you can pause the video and see these graphs, or you can also try them. Then I would be using another CSV file, which is day underscore wise dot CSV, which provides day wise data of all the confirmed deaths, recovered, active, new cases, etc. etc. for all the countries. I would be importing plotly.express as px. For those who don't know what is plotly, it's similar to Seaborn, but it is slightly at a higher level, more than Seaborn. Like, it's used for better realization of graphs. We can also use Seaborn to do this, or we can also use Matplotlib. Uh, as px, and then we are using the line plot. We will be plotting the graph using line plot, so we'll call the line method px dot line, and our data frame is this. X variable is date and y is equals to, so we are using around 4 y functions because we want a graph for every particular value, like confirmed deaths, recovered, and active. So here is a beautiful visual which we got. As you can hover over the line, you can also see date and the value of the particular quantity, which is shown according to the colors in this line. This is dark blue, which is confirmed. This is green, which is recovered. This is purple, which is active, and this is red, which is deaths. So you can also like see everything using it. Moving forward, I would like to watch my database, which was world underscore data again. So I wrote world underscore data dot head, and then what I'll be doing is I want my population tests ratio, so I'll be creating another column in world underscore data named as population tests ratio, and then according to this indexing, I'll be finding the population tests ratio, which would be total tests upon population into 100. So I'll get the population tests ratio, and then I'll be again graphing it using Seaborn. My X variable would be country or region, and my Y variable would be population tests ratio. So here is what was got. Note, this is for the particular first top 20 countries only. So UK had the maximum population tests ratio percentage, followed by Russia and followed by USA. You can see for each and every country using Seaborn, and then we are building the graph for total cases, which I guess we built once. And in the next case, what we are doing is we are using px plotly to graph using the bar method, and we are using the data frame of the first 20 countries. Our x variable is country slash region, and our y variable is total cases, total deaths, total recovered, active cases, and serious comma critical. So for each and every block, you can see there is a color associated to it and a variable, such as dark blue is for total cases and purple is for active cases. So the total cases are maximum like in USA, and you can also compare every block, each and every block using this graph. And as you can see, Plotly can be used at a higher level than Seaborn, which can be proved from this graph which I built using Plotly. Next, what we will be doing is we will be plotting a pie chart. Yes, you can also plot a pie chart using px.py, again Plotly rules. The values would be total cases and names would be country slash region. So as you can see, 31.5% cases were from USA, 18.3% cases were from Brazil, and 12.7% cases were from India. You can see for every other country using this, and you can also hover over a particular color and you can see the values associated with that color. So this is it from this, and now what we'll be doing is we'll be converting this ratios into, and we'll be creating columns for it. Suppose we'll be converting this deaths to cases, like how many deaths per some cases, how many deaths per recovered, how many tests per cases, how many serious to deaths. So we'll be creating columns for each and every entity and we'll be building graphs for it. How many deaths per cases, you can see here. uh, this entity was maximum for France, then UK, then Italy. So next, deaths to recovered, this entity was maximum for France. Tests to cases, this entity was maximum for Mexico. Serious to deaths, this entity was maximum for Saudi Arabia. Like how many deaths when the patient were serious. So this was something to be derived from this data frame. Something important which was derived from this data frame. We played with the data frame and we successfully considered all the important columns and extracted some useful information from it and plotted it in a very efficient way such that everyone can understand, not only an expert, a noob person can also understand it. So this is it from COVID-19 data analysis. Thank you for watching.